Below is an expanded, more engaging version of the passage, roughly double in length, written with correct grammar and additional details. It envisions both the historical asteroid impact that ended the dinosaurs and a modern-day what-if scenario, how humanity might confront a comparable threat today. A perilous legacy from 66 million years ago. 66 million years ago, dinosaurs still roamed the earth as undisputed masters of land, sea, and sky. Massive herbivores grazed across lush plains, while fearsome carnivores hunted with razor-sharp teeth and claws. Few creatures, let alone the dinosaurs themselves, suspected that their world was on the verge of a cataclysm that would sweep away entire ecosystems. Yet that's precisely what happened when a mountain-sized space rock hurtling from the asteroid belt between Mars and Jupiter smashed into our planet. The colossal impact carved out a crater, an astonishing 115 miles in diameter and over 12 miles deep. In its wake, a brutal chain of events led to the extinction of the dinosaurs, along with nearly 75% of all life on Earth. That ancient calamity, often referred to as the Chicxulub event, still captures our imagination. Scientists estimate that the asteroid measured around 6.5 miles, about 10 kilometers, in diameter, more than large enough to end countless eras of evolution in one devastating blow. It arrived at a blistering speed of nearly 45,000 miles per hour, slamming into Earth's surface with an energy release of 100 teratons of TNT, equivalent to 2 million of the largest nuclear bombs ever devised. To make matters worse, paleontologists and geologists suggest that this space rock hit our planet at precisely the worst possible location, near Mexico's Yucatan Peninsula. The composition of Earth's crust there, rich in sulfur-bearing rocks, proved catastrophic when vaporized, sending up a dense, sunlight-blocking haze that triggered an extended impact winter. So the question arises, what if a similarly sized asteroid, traveling at roughly the same speed, barreled toward Earth today? Could modern technology save us where the dinosaurs once failed? We can piece together a hypothetical doomsday scenario by blending what we know about the ancient asteroid and the tools we possess for planetary defense. Yet even with decades of research and advanced space programs, the outcome might still be disconcertingly grim. The asteroid that remade the world first. Let's re-examine the asteroid that ended the dinosaurs and, in many ways, paved the way for mammals, and ultimately humans, to inherit the Earth. Known as the Chicxulub asteroid. It was no modest space pebble. At around 6.5 miles wide, it dwarfed most city skylines. Upon entering Earth's atmosphere at 45,000 mph, or about 20 kilometers per second, its kinetic energy alone was staggering. Some scientists compare this to 2 million tsar bombas exploding simultaneously, referencing the most powerful nuclear weapon ever tested. The crater it left behind in Mexico's Yucatan Peninsula, named La Chicxulub, extends 115 miles across and dips 12 miles deep. The explosion blasted molten rock, superheated winds, and enormous plumes of ash and dust high into the atmosphere, circling the globe. Tidal waves, earthquakes, and wildfires soon followed. Over the subsequent months and years, sunlight was blocked by airborne particles, halting photosynthesis and collapsing ecosystems worldwide. The dinosaurs, long the dominant form of life on Earth, found themselves in an environment turning rapidly hostile, with scorching heat soon replaced by a punishing global chill. Unable to cope, they vanished from the evolutionary stage. The modern threat, sneaky and dark, Asteroids. In our era, you might think that space agencies like NASA, ESA, and others have a comprehensive handle on all potentially hazardous near-Earth objects. Indeed, we have sophisticated telescopes and sky surveys scanning the heavens. Yet astronomers and astrophysicists warn us that thousands of these planet-killer asteroids could be on trajectories we haven't fully mapped. Dark and unreflective asteroids remain especially elusive because they reflect minimal sunlight and can slip through observational blind spots. One unsettling example is the first known interstellar visitor, Oumuamua, a roughly 400-foot-long, strangely shaped rock, sometimes likened to a cigar or a pancake, that passed our solar system in 2017. Astronomers only spotted it on its way out, after it had already journeyed past the Sun. Though it was much smaller than the Chicxulub asteroid, its sudden appearance and high velocity demonstrate how easily a sizable space rock could surprise us. To complicate matters, our existing telescopes on Earth have difficulty scanning the region of space near the Sun. An intense glow often blinds us to objects hiding behind it. A massive asteroid approaching from that direction might not be detected until it's far too late. Currently, we have limited technology to deflect or destroy such a threat. Missions like NASA's Double Asteroid Redirection Test, DART, show promise in altering an asteroid's path, but the spacecraft tested was designed for smaller targets, nowhere near the size of Chicxulub. The what-if scenario. Playing out a doomsday. Let's imagine that astronomers detect a new object, a black smudge crossing the face of the Sun. It's soon identified as a 6.5-mile-wide asteroid, traveling at 45,000 mph, about 90 million miles away, giving Earth just 83 days before impact. Governments initially attempt to conceal the discovery, fearing worldwide chaos. But the secret quickly leaks. Amateur astronomers confirm the object's approach. Panic spreads as news outlets beam headlines like, "Asteroid on collision course, 83 days to impact." The efforts to save the planet. In a massive cooperative effort, international space agencies convene. Different concepts are proposed. 1. Gravity tractor. A spacecraft would hover near the asteroid to exert slight gravitational pull, nudging it off course over time. The problem? You need years of lead time for such a gentle method to succeed. With only 83 days, that's impossible. 2. Kinetic impactor. Similar to the DART mission, a massive projectile could slam into the asteroid, hoping to shift its orbit. But a mountain-sized rock traveling so fast would likely require an enormous impactor and multiple attempts. Even then, it might only break the asteroid into multiple large fragments, each capable of devastating the planet. 3. Nuclear detonation. The most dramatic option is to launch nuclear warheads at the incoming threat, but a nuclear blast in space or near Earth's atmosphere poses its own risks. If the asteroid fragments into dozens of pieces, many smaller impacts might still cause continent-wide devastation, and there's no guarantee the warheads will significantly alter its course. Given these constraints, officials realize that success is highly unlikely. The plan might reduce some part of the damage, but with the clock ticking, the best approach might be to evacuate as many as possible from the predicted impact zone and brace for the worst. Public panic and social unrest word inevitably gets out, and society unravels. Within days, cities near the projected impact site, likely near Mexico's Yucatan region, echoing the Chicxulub event, witness a mass exodus. Highways become clogged with vehicles. People hoard food, water, and medications. Store shelves empty, black markets surge. Families with resources secure spots in deep bunkers or relocate to mountainous regions, hoping to evade tsunami waves. Governments try to maintain order, issuing curfews, rationing supplies, but fear and desperation escalate. Throughout this chaos, scientists and emergency management experts broadcast instructions for underground shelters. Cheyenne Mountain Complex, built decades ago for nuclear war scenarios, becomes a refuge for key political leaders and top military officials. Rumors swirl of secret bunkers designed for ultra-wealthy individuals. For the vast majority, a robust underground option simply doesn't exist, forcing them to improvise or risk staying above ground. Impact Day. The world stands still. With only hours left, the asteroid looms like a growing fireball in the sky, plainly visible to anyone. It brightens to a terrifying radiance, trailing a molten glow. Panic reaches a fever pitch, yet some pockets of people gather for prayer or communal solace. In the final moments, Earth's satellites detect a colossal heat signature as the asteroid enters the atmosphere at 12.5 miles per second. Friction superheats it, creating a sonic boom that cracks windows and sends wildlife scurrying. In mere seconds, the space rock slams into Earth with an impact force measured in the millions of 50-megaton nuclear bombs. A blinding flash radiates outward, followed by a shockwave so intense it registers as magnitude 11 plus on the Richter scale. The ground quakes, splitting open roads and toppling structures thousands of miles from ground zero. Massive tsunamis over 3 miles high crash into coasts across the hemisphere, flooding entire cities. North America and neighboring regions are instantly ravaged by superheated winds exceeding 600 mph, vaporizing forests and incinerating animals in a radius spanning hundreds of miles. The aftermath. Global devastation. Within hours, Earth's skies darken under a shroud of dust, ash, and sulfuric compounds. The vaporized crust injects 25 trillion metric tons of molten ejecta into the atmosphere, triggering wildfires on a near-continental scale. The nuclear winter effect sets in quickly, blocking sunlight so thoroughly that temperatures plummet. Plants outside of certain shelters or artificially lit greenhouses wither and die, toppling ecosystems. Acid rain scours surfaces, corroding metal structures and poisoning water supplies. In the weeks that follow, an alternating cycle of cooling from the dust and warming from rampant CO2 outgassing confuses Earth's climate. Ice caps melt, ironically flooding some areas, even as other places suffer brutal cold. Meanwhile, the oceans teem with debris and chemical imbalances, devastating fish, whales, coral reefs, and other marine life. Scavengers feast on carcasses, but soon find resources too scarce. The great mass extinction is underway. Human struggle for survival. Deep underground bunkers become the last bastions of human life. Those with adequate provisions, canned food, water filters, medical supplies, might endure for several months or even years. However, these survivors face staggering challenges. 1. Supply shortages. Canned goods and dried foods eventually run low. Rationing becomes essential. Many bunkers never anticipated a multi-year lockdown and soon face starvation if they don't venture above ground. 2. Medical crises. Diseases proliferate in cramped conditions. Weakened immune systems, combined with stress and potentially tainted water, lead to outbreaks of illnesses. Antibiotics and other supplies run short. 3. Psychological toll. Enclosed environments, lack of natural sunlight, and the loss of friends and family weigh heavily on survivors. Anxiety, depression, and post-traumatic stress become widespread. Community support or mental health initiatives might help, but resources remain scant. 4. Surface exploration. Once the dust begins to settle, some braver groups attempt to scout the surface. They encounter charred landscapes, radioactive hotspots, if nuclear attempts were made to destroy the asteroid, and collapsed infrastructure. Growing food outdoors is nearly impossible due to lack of sunlight and acidified soil. 5. Innovation and ingenuity. Despite the grim situation, human resilience sparks creative solutions. Hydroponic systems are set up in subterranean chambers using artificial lighting powered by generators or improvised solar collectors. Small communities might figure out how to harness geothermal heat or salvage electrical components from abandoned facilities to create rudimentary power grids. A new world emerges. Over the span of decades, maybe centuries, the Earth gradually stabilizes. Dust settles, and sunlight returns to some degree. Temperatures climb from near-freezing lows, though the climate remains erratic. Surviving fauna and flora adapt to the drastically altered environment, filling ecological niches left empty by the mass die-off. Human enclaves grow into fledgling city-states. Skills like farming, engineering, and medicine become priceless, while luxury goods fade into myth. Coastal topography changes radically due to tsunamis and sea level shifts. Large swathes of coastline lie submerged, forming new inland seas, while some older seafloors now sit as deserts above the waterline. Amidst the rubble of once great metropolises, pockets of technology remain. Data servers might hold fragments of humanity's collective knowledge waiting to be rediscovered. Archaeologists of the new epoch may excavate the remnants of skyscrapers or highways, marveling at the advanced civilization that perished almost overnight. Hope among the ruins. Though battered, humanity endures. People learn to reconstruct rudimentary industries, smelting metals from debris, rigging up water purification from salvaged filters, and even forging new alliances across scattered communities. The trauma of the asteroid strike lingers in collective memory as a cautionary tale about complacency and the dangers of cosmic threats. Some dream of re-establishing spaceflight, reasoning that the best way to prevent another cataclysm is to track and potentially deflect incoming asteroids far in advance. Others champion a more grounded focus, urging that survival skills and ecological balance come first. Over generations, these debates shape new cultures, philosophies, and moral codes. In a broader sense, this near-extinction event underscores the precariousness of life on a single planet. If any lesson resonates from the Chicxulub analog, it's that cosmic hazards can strike at virtually any time. Our technological advancements may help us, but only if we actively prepare, remain vigilant, and invest in planetary defense well before we glimpse a fiery rock across the horizon. Girar, the final word and your voice. Imagining a doomsday asteroid is unsettling, yet also compelling. It reminds us how thin the line is between thriving civilization and utter devastation. In truth, we still have significant gaps in our detection strategies and our readiness to deflect a large space rock. This hypothetical scenario, though dire, might inspire global cooperation, because the threat of an impact doesn't discriminate between nations or ideologies. We invite you, the reader or viewer, to ask yourself, could humanity realistically survive such an impact? How would you react if an observatory announced an 83-day countdown to collision? Would we unify to deploy creative solutions, or would panic rule the day? While no one has the ultimate answer, discussing these possibilities can spark vital research and vigilance. Thank you for joining us on this expanded journey through cosmic history and hypothetical disaster. If you found it interesting to explore how a Chicxulub-scale asteroid would affect modern Earth, we encourage you to share your thoughts. What defenses would you propose? Where would you hide out? And how can we ensure our species doesn't end like the dinosaurs did? Stay tuned for more explorations of astronomy, geology, and all things beyond our everyday lives. Remember, the same cosmic processes that shaped Earth's past may well determine our future. By staying curious and collaborating across borders, we might just keep ourselves from going the way of the T-Rex and perhaps carve out a brighter chapter in Earth's ongoing saga